Hello friends, greetings from Professor EME-Vyas. Friends, we are learning properties of gas. We have gone through the various topics of properties of gas. What we have learned till date, let us recall. In the properties of gas, we have learned the vapor and gas. What is vapor and what is gas? After understanding the difference between the vapor and gas, we have studied the Boyle's law. Then we have studied the Charles law. Based on these two laws, we further moved and learned about the combined gas law. After understanding the combined gas law and characteristics gas equations, we also learned the specific heat, Avogadro hypothesis, gas constant. We also learned the relationship between the Cp and Cv, where Cp is the specific heat for a gas at a constant pressure, Cv is specific heat for a gas at a constant volume. We have learned that where solid and liquid has one specific heat, where gas has two kinds of specific heat, Cp and Cv. We establish the relationship between Cp and Cv. Then we move to the non-flow process. So two kinds of the process. One is the flow process, another is the non-flow process. What is flow process? That we also learn. And what is the non-flow process? Under the non-flow process, we learn the first, the constant volume process. Then we also move and look into what is the constant pressure process. So when during the process, when gas undergoes some kind of the process in an engine or a closed vessel, the volume remains constant. It is the constant volume process. When the pressure remains constant, it is constant pressure process. Then we also learn the constant temperature process, which is called isothermal process. When the gas undergoes the process, during that process temperature remains constant. It is known as constant temperature process. Friend, today we are learning another one very important process of these properties of gas, that is the adiabatic process. So what is in adiabatic process? We are today going to learn adiabatic process. Adiabatic process is one kind of thermodynamic process, one kind of thermodynamic process. What happened? In this process? Here in adiabatic process, there is no heat interactions during the process. No heat interaction during the process. What do you mean by the no heat interactions during the process? No heat interaction means Q is equal to 0. No heat interaction means Q is equal to 0. So what happened? Gas neither receives the heat nor gives out the heat. The gas neither receives the heat. Suppose this is an engine, inside there is a gas, that means the entire this area outside it somehow by any means insulated. It is insulated in such a way that the Q remains zero, no heat interactions, But there is a work interaction. But there is a work interaction. There is work interaction. So, neither heat is supplied nor heat is rejected out. Q neither supplied nor rejected out. But the work interaction is there. So, the work is done. So, the work is done at the expense of its own internal energy. The work is done at the cost of or at the expense of its own internal energy. There is no heat transfer, but work is there, and this work is done at its own internal energy. So friends, when there is the change in internal energy, work is done because there is a change in internal energy. Change in internal energy, and as there is a change in internal energy, it results in the change in temperature. Change in temperature. So what happened when in cylinder piston arrangement the gas is inside, the temperature increases. The temperature increases when there is a compression. When there is a compression, and temperature decreases when there is a expansion. When there is a expansion. So this frictionless, when this adiabatic process, it is frictionless. It is a frictionless, then it is known as adiabatic process, when it is frictionless, it is known as isentropic process. It is known as isentropic process. Frictionless adiabatic process known as isentropic process. Friends, in this adiabatic process, it is very important to derive its equations which establish how the process goes on, and that equation is known of the law of adiabatic process. That equation is known as law of adiabatic process. The law of adiabatic process. What is this law of adiabatic process? Let us see and try to understand it. The first law of thermodynamics. The first law of thermodynamics. According to the first law of thermodynamics, what the first law of thermodynamics says? The first law of thermodynamics says that heat supplied is equal to change in internal energy, plus work done. The first law of thermodynamics says that the heat supplied is equal to the change in internal energy plus work done. So, change in internal energy, it is nothing but dq, the small change in internal energy. Heat supplied is equal to dq. The change in internal energy, that is Cv into dt, plus work done is equal to P dV. The work done is equal to P dV. Let us say this is your equation A. This is your equation A. Heat supplied is equal to change in internal energy, dq is equal to Cv into dt, plus work done P into dV. We are interested for adiabatic process. And in adiabatic process, we have seen that dq is equal to 0. There is no change in the heat. Heat neither be given nor be taken out. So dq is equal to 0. Therefore, equation 1, it becomes, therefore, equation A becomes Cv into dt plus P dV is equal to 0. Let us say this is equation B. This is equation B. Now, we are interested to establish the law of adiabatic process for the gas. So, consider for 1 kg mass of gas. For 1 kg mass of gas, you can write down your characteristics gas equation. You can write down the characteristic gas equation. What is characteristic gas equations? P into V is equal to MRT. When M is equal to 1, for 1 kg of mass, it is P into V. For 1 kg of mass, it is P into V is equal to RT. P into V is equal to RT. So, P into V is equal to RT. Differentiating this equation, what you will get if we differentiating the above equation, what we will get? We will get P into dV plus V into dP is equal to R into dt into R into dt. Now substituting for dt in equation B. So, what is equation B? We have a equation B. In our case, earlier equation B which we have got, that is CV into dt plus P dV is equal to 0. This is our equation B. CV into dt is equal to P into dV is equal to 0. Right? So, in this equation B, put the value of dt, for value of dt from this. Here, you can write down the dt is equal to P into dV plus V into dP upon R. Put this value over here. So in this equation, you will get CV into dt is equal to P dV plus V dP upon R. This is your dt plus P dV is equal to 0. Your equation B, CV into dt, instead of dt we are substituting the value of dt which we have derived from this, that is P into dV plus V into dP upon R, that we are putting. So CV into this value of dt plus P dV is equal to 0. So simplifying, therefore Therefore, CV into PdV plus VdP bracket complete R multiplied by PdV is equal to 0. What we did, we take out this R, throughout all this common. Therefore, CV into PdV plus VdP plus what? You have to put the value of R here. Put the value of R here, that is what? Cp minus Cv. It is Cp minus Cv. Instead of R, we are putting Cp minus Cv into PdV is equal to 0. Further simplifying, open this bracket. You will get Cv into P dV plus Cv into V dP plus Cp into P dV minus Cv into P into dV is equal to 0. This is equal to 0. So, what will go out? This will be cancelled out. Cv into PdV, Cv into PdV minus Cv into PdV, these two terms will go out. It is left only these two on left hand side. Right hand side is 0. So it is Cv into V dP plus Cp into P dV is equal to 0 is left out. Now, these equations, divide these equations by dividing the above equation by Cv into P into V. So, if we put that in above, with the above equations divide Cv into V into dB divided by Cv into P into V plus Cp into P in Cp into P into dV upon Cv Pv is equal to 0. So here this will be cancelled out. Left out is dP upon P plus here P will be cancelled out. So Cp upon Cv multiplied by dV upon V is equal to 0. Now, if we integrate the above equation, above equation. And put Cp by Cv is equal to gamma, and if you put Cp by Cv gamma, what you will get, suppose this integrating dP by P plus Cp by Cv integrating dV by V is equal to 0. So 1 upon x log dx, 1 upon x dx gives you the log dx, so 1 upon p dp is nothing but log p to the base e, and Cp by Cv is gamma, again it is log v to the base e. Integration of 0, this integration gives you the constant, and that is log c to the base e, log c to the base e. This c is the constant, this c is the constant. This is constant. So therefore log p to the base e plus log v to the base e raised to gamma is equal to log c to the base e. Further simplifying this, applying the logarithmic rule, or if you remove it, then you will get p into v raised to gamma is equal to c, is equal to constant, or you can say the c. This is what is established, the law of adiabatic process. What we have established, the law of adiabatic process. Now here this V is specific volume, basically small, this is small volume, and that specific volume V is specific volume, that is equal to the total volume per unit mass. Total volume per unit mass, put this value over here, it is P into capital V raised to gamma upon m raised to gamma is equal to C. If we multiply this, P into V raised to gamma is equal to m raised to gamma into constant C. So is another constant, you can say another constant C. This C is new constant, it is defined the new constant. P into V raised to gamma is equal to constant. So this we have established the relationship, or you can say the law of adiabatic process. So friend, till what we have done, we have understood what is the adiabatic process, and we have established, we have seen the law of adiabatic process. Now we are interested next what we did in all previous three processes, what we did, the relationship between P, V and T. So here we are also interested the relationship between P, V and T. Then we will see the work done, then the change in internal energy and the change in enthalpy and the heat transfer we will see one by one. So the relationship in PVT, we have already seen that P into V raised to gamma is constant. So we have studied that P into V by T is equal to constant. PV by T, that we have studied, it is constant. So you can say that P1 V1 raised to gamma is equal to P2 V2 raised to gamma. So from here you can write that P1 upon P2 is equal to V2 upon V1 whole raised to gamma. This is P1 upon P2, V2 upon V1 whole raised to gamma, or in other words, you can write down V2 upon V1 is equal to P1 upon P2 whole raised to 1 upon gamma. Whole raised to 1 upon gamma. Let us say this is your equation 1. Now if these two equations, if we divide, we will get volume gamma minus 1 into T is equal to constant. If we divide P into V raised to gamma divided by PV by T, so V into gamma minus 1, V raised to gamma minus 1 into T is equal to constant, and you can write down that V1 raised to gamma minus 1 into T1 is equal to V2 raised to gamma minus 1 into T2. Let us say this equation 2. What we did, P into V raised to gamma divided by P into V by T, so P will be cancelled out, V raised to gamma minus 1 into T is constant. Based on this, you can write down V1 raised to gamma minus 1 into T1 is equal to V2 raised to gamma minus 1 into T2. This is, say, the equation 2. From this equation 1 and 2, from this equation 1 and 2, you can write down T1 upon T2 is equal to P1 upon P2 whole raised to gamma minus 1 upon gamma is equal to V2 upon V1 gamma minus 1. From these two equations, T1 upon T2 is equal to P1 upon P2 gamma minus 1 upon gamma is equal to V2 upon V1 gamma minus 1 V2 upon V1 whole raised to gamma minus 1. P1 upon P2 whole raised to gamma minus 1 upon gamma is equal to V2 upon V1 whole raised to gamma minus 1. These equations 3 will give you the relationship of adiabatic process for PV and T. This establishes the relationship between the PV and T under the adiabatic process. Now let us say the work done during the process. The next aspects we are interested is second, work done during the process. So let us see the process on PV diagram. This is PV diagram. When there is an expansion process takes place, means gas expanded inside the cylinder, process starts from 1 to 2. It starts from this point 1 to 2. And when it is the compression process takes place, process starts from 1 and it goes to point 2. This is at point 1, at point 2. So the work is area under this. The work is area below this curve. The work is nothing but the area below this curve. So you can see the work done is W. Work done is W integral P dV from V1 to V2, from V1 to V2. Here you are knowing that P into V raised to gamma is constant. P into V raised to gamma is constant. So we can write down the P1 V1 gamma, P2 V2 raised to gamma is equal to constant. Right? So therefore P is equal to C constant upon V raised to gamma. So work done W is equal to integral from V1 to V2. Instead of P, we are putting this C, V raised to gamma dV. Taking out C common, V1 to V2 dV upon V raised to gamma. So integral 1x raised to y dx gives you x raised to minus y plus 1 upon minus y plus 1. That means here 1 upon v raised to gamma is equal to c v raised to gamma minus gamma plus 1 upon minus gamma plus 1 running from v1 to v2. So putting this value in place of v, first we put v2 and then next time we put v1, you will get c upon minus gamma plus 1 common. Inside it is v2 gamma minus gamma plus 1 minus v1 minus gamma plus 1. We know that the c is what? This is the value of c. P1 into V1 raised to gamma is equal to P2 into V2 raised to gamma is equal to the constant. Substitute this value over here in this C. Let constant, this C is constant. We will get work done W is equal to 1 upon minus gamma plus 1 into P2 V2 raised to gamma into V2 minus gamma plus 1 minus second time when it is the constant C, instead of C we are putting P1 V1 raised to gamma into V1 raised to minus gamma plus 1. So simplifying this you will get P2 V2 minus P1 V1 upon 1 minus gamma, because V2 raised to gamma and V2 raised to minus gamma will be cancelled out, left out only V2, P2 into V2. Same way V1 raised to gamma, V1 raised to minus gamma will be cancelled out, left out only V1, so P1 V1. So therefore you can write down the work done is equal to P1 into V1 minus P2 into V2 upon gamma minus 1. We have rearranged these minus terms or introducing the minus throughout, so you will get in a rearranged form work done is equal to P1 V1 minus P2 V2 upon gamma minus 1. And if we take this P1 V1, so if we use P into V is equal to MRT, so P1 V1 is equal to MRT1, P2 V2 is equal to MRT2. Putting this value work W is equal to M into R P1 V1 minus P2 V2. Instead it is T1 minus T2 upon gamma minus 1. What is R? R is nothing but Cp minus Cv. R is nothing but Cp minus Cv. So M into Cp minus Cv into T1 minus T2 upon gamma minus 1. Now Cp by Cv is equal to gamma. We know that gamma is equal to Cp by Cv. So this is nothing but basically gamma upon 1. So therefore you can write down the gamma minus 1 upon 1 is equal to Cp minus Cv upon Cv. Use these things over here. Put gamma minus 1 is equal to Cp minus Cv upon Cv. So by putting this value over here, we will get work done is equal to M into Cp minus Cv into T1 minus T2 upon gamma minus 1 is nothing but Cp minus Cv upon Cv. That Cv goes to the numerator, so that Cv is here. So what you will get, this will be cancelled out. Cp minus Cv will be cancelled out. At last you will get N Cv T1 minus T2. Work done is W M into Cv T1 minus T2. You know that heat transfer, third point, heat transfer, that is 0. dq is 0. The change in internal energy, that is del q is equal to del w plus du. Now del q, this is 0, so du is equal to minus del w, right? So what it indicates, whenever there is in adiabatic process, the change in internal energy is equal to the work done, right? And the last is change in enthalpy. Change in enthalpy, that is equal to delta H is equal to mCp T2 minus T1. mCp T2 minus T1. So friends, we have learned the adiabatic process. We have established the law Pv raised to gamma is equal to constant in adiabatic process, and then we have seen the various aspects, that is the work done, relationship between Pv and T, heat transfer, change in internal energy, and change in enthalpy. I request friends, you go through the good books, do some practice of the numerical problems which we have already done. Next time we will do small exercise based on this adiabatic process. Till then, a very happy time and all the best to all of you. Thank you very much.